Good morning, everyone. It's great to see everybody here. So we started this journey about 4 years ago at Facebook. I still fondly remember that we announced our intention around OCP in the cafeteria of one of our office buildings. In the background was our chefs preparing lunch for the entire company. We had pretty humble beginnings. This is actually an original, or a photo of the original design of the electrical scheme that actually today still powers our data center. So you can see here that this scribbling on a napkin at 2 o'clock in the morning is actually where we started 4 years ago. Now we've come a long way, and I think in the last 4 years, you've seen us build up our momentum here of the different contributions that we put. And in front of you on the slide here is all of the contributions, or most of the contributions, that Facebook has put forth into the community and contributed to OCP. You can see here back in 2011, we started with very basic building blocks. We contributed ideas, designs for the mechanical and the electrical systems in the data center. We then designed and contributed, worked on the power supplies, the battery cabinets, and then we started building up just a very basic server to kind of get started here. And over the years, we've been building up on our experience and how these designs have been operating in our data center and tackled harder and harder problems. So in the most recent years, you can see us expanding the types of server products we've built. We've tackled storage, different types of compute. We've worked in cold storage. We've redesigned the rack twice. Now, not everything up here actually worked the first time. We announced Group Hug a couple of years ago, and it was a good first start, but it didn't quite work out for how our workloads were evolving in our data center. But it then did inspire and helped us come up with projects like Honey Badger as well as Wedge, which I'll talk a little bit about in a bit. Now, the cool thing about this is that our contributions here aren't just specs and pretty pictures that are part of the OCP Summit. This stuff is actually the stuff that's going into our Facebook data center today, right? So this stuff is live in production. It is what powers everything on Facebook today. In fact, late last year, we opened up our newest data center in Altoona, Iowa. And this data center, like our data center in Luleå, Sweden, is fitted out with 100% OCP gear. Now, the impact to Facebook is actually really, really large, because not only is it that it's operating our data center, but what does this data represent, or this data center represent for Facebook? It represents the following. There's 1.39 billion people using Facebook. There's over 500 million people using Facebook Messenger. There's over 300 million people using Instagram. And this is some of the activity that you can see that's happening on a daily basis in Facebook. So there's over 3 billion views of video views that happen every day. There's over 890 million people that visit Facebook on mobile every day. And then there's also a ton of photos that are coming into the system across Instagram and Messenger and the main app that are being shared, and that we have to build infrastructure to support that serving. So this infrastructure that I've talked about, all of the stuff that we've done here in OCP, has not only just helped us scale Facebook and the main Facebook application and website, it's now helped us, because of the design premise around flexibility, has now helped us scale out to other services that we've been building. So why does this all matter? Well, beyond being able to support this community of people that use Facebook and Instagram and WhatsApp and Messenger and other properties, the bottom line for us is actually pretty large, right? So we've actually, as I talked about last year, had this approach to working on efficiency from the get-go. We thought and baked in working on efficiency as a first principle when we launched OCP 4 years ago. And I talked last year about this sort of concept, or this philosophy that we have around full stack optimization. Being able to look at the data center, the network, the hardware, the software, the operations, end to end, and really trying to figure out how to move the needle on making this infrastructure more cost efficient. Last year, I threw out a number of $1.2 billion that we had saved over 3 years. I wanted to update that number. We are currently tracking at over $2 billion that's been saved over the last 3 years. Now, this is a full stack optimization. This is being done through optimizations that we do in the data center, in the software, in the network, and in the hardware, and thinking about how all of this progresses in future years. So this is going to be a continued focus for us in our designs and how we think about building out our infrastructure. Now, not only is it flexible, that it's been able to help us serve all of these different applications, it's also saved us a lot of money, as you can see, but it's also been great from an energy conservation perspective and a sustainability perspective. So we've been able to here actually over the last year kind of do some calculations, and over the power that we save through these designs is equivalent to about 80,000 homes, powering 80,000 homes for a year. And the carbon emission reduction is about 400,000 metric tons that we've saved, which is equivalent of taking 95,000 cars off the road for a year. So this stuff really does matter when you think about this optimization. It gives us the flexibility to sort of adopt and sort of build for the ongoing mission of the company. It helps us save money and build this infrastructure out efficiently, and it builds it out in the most energy efficient way possible. Okay, so beyond talking about these designs and these systems that we've built, one of the things that we've believed at Facebook in sharing with this community and really kind of incubating in this community is philosophies around how to build infrastructure. Last year I talked about full stack optimization. We've shared information on renewable energy and how to manage that and incorporate that into your infrastructure. We've talked about other things like network, et cetera. One of the themes that we've talked a lot about for many years is this concept of disaggregation. At the highest level, we believe that you need to take sort of these bigger building blocks, these bigger pieces of infrastructure, and over time break them down into smaller components, and then use those components to then build up very quickly to what you need to solve for in the business. I want to give an example here, a latest example of a system called Multifeed. And Multifeed is one of many systems that we use to power newsfeed. So when you log into Facebook, you see this newsfeed, which is your personalized, highly personalized, current kind of news that's relevant and pertinent to you. This is a massive operation. It's really, really complicated. Traditionally, we've put what we've talked about is the leaf and the aggregator. These are two software components, each kind of working together but doing different things. We put them on the same type of server, and we've just like maxed out that server. We put a lot of CPU, a lot of memory, really kind of just beefed that up and said, hey, these things are all going to be next to each other. They need to talk to each other. But what we found out is that over time, as we understood our workloads and we started to see the product itself change and get more and more dynamic, more and more kind of product features were going into it, the ranking got more sophisticated, the content was getting richer. We saw that this model was not as efficient as we needed it to be or wanted it to be. So we kind of we looked at this and we sort of said, if we had to rethink this architecture, where would we go with this? And we moved to this new kind of model here, where in concept, we split out the aggregator and the leaf. And so we were able to take the software, make adjustments to it to really map well to the underlying hardware design and the architecture that it was powered by. So we were able to optimize threading models. We were able to maximize and optimize the memory management and really get ourselves into a better place so that we could minimize context switches in the software. And the biggest win for us is that as the product continues to evolve, as we continue to try to make this highly personalized experience better and better and over time, that we can adjust the ratio of these type A and type B servers independently of each other without wasting a lot of different compute resources. In the past, when we were all stuck on one type of server, if the product team decided to change the way it was ranking stuff, you might have consumed a lot more CPU and had to throw a lot more machines at the problem, but then you would strand a lot of memory, a lot of network, a lot of storage. Now we're able to control these two independently and be able to adjust more real time with the evolution of the product. So this really, really gives us an awesome win from a flexibility perspective. Now beyond that, it's had a massive improvement efficiency-wise for us. So we've seen a 40% win on efficiency just by implementing and changing this architecture. So, when it comes to sort of disaggregation, this really does work. We really believe this. We're applying it every day in every part of our infrastructure. And here's like the most recent example of where we've seen this really be beneficial to Facebook. Now, I showed this slide earlier, but we've come a long way in 4 years, but what's left? What are we doing? There's still a lot more to do. We are nowhere near being done of what we're trying to accomplish. You've seen some news from us recently in the last month or so talking about this new network switch called 6-pack, which is on your far right. Last year, we talked about Wedge, Fabric, which is our new data center network topology, and then FBOSS. These 4 pieces combine together to really bring out what we think is the open network for the data center. Now, we've talked a lot about these devices and this software and this architecture, but today I want to talk a little bit about sort of, what's happening this year. And a big part of this stuff is we want to make this stuff easier to consume for the community, for you all. So today I want to announce a few things. Now, this is Wedge, and we announced Wedge last year. Today, we are contributing the Wedge spec. The specification itself is going into OCP. So it'll be there for everybody to be able to take, be able to implement, be able to improve, and work with the community. So the spec is being contributed to OCP. Furthermore, if you want to get your hands on Wedge hardware, you're going to be able to call up Acton, and they're going to have devices available for sale in the first half of this year. So this is no longer just a spec. It's no longer just an idea from Facebook or something that Facebook itself can deploy in our data centers. It's available to you. So you will have access to this hardware that is running in Facebook's data center. Now, you might be asking, you're like, great, Jay, I got hardware, but what am I going to do? How am I going to run this thing? Cumulus and Big Switch are announcing today that they will be supporting the software. So if you want a plug-and-play software solution on the switch, the Wedge hardware itself, you'll be able to talk to Cumulus and Big Switch to get access to their operating system and their installer to run the software on the devices. Now, if you decide to go down the non-plug-and-play route and want to kind of roll your own or do a more custom development on this, then there's a custom track for you guys. Broadcom is now releasing an open networking switch library that is accessible for you to build on top of to be able to control their underlying switch ASIC. We're also, Facebook is releasing a package called the FBOSS, which is our Facebook operating system for our switches. We're releasing an agent that will help you do that and get there faster. So it's kind of a starter library that will sit on top of OpenNSL, which will help you then be able to write this custom software that you may want to do. So there's sort of like lots of different options here, right? You can get access to the hardware. You can just go plug and play with Big Switch or Cumulus. Or if that's not what you want and you want to invest and sort of roll your own, then there's a great way to get started with the work that Broadcom has done and also looking at the Facebook FBOSS system to get you started. Now, the last piece here, and it's an obvious one, but we need to do basic board level management of these devices. So we are releasing a new software library called OpenBMC, and it's kind of what it sounds like. It's an open source version of BMC software so that you will be able to integrate that with and run that so that you can manage your network devices. But this OpenBMC library, this software, can theoretically be applied to any device that you need BMC control over. So all of this is going to be available today. There are follow-up sessions today in the rest of the day to do deeper dives on these releases. So I just want to give a big round of applause to the companies here that have put forth all this great effort. OK, so I want to switch gears a little bit, kind of come back to this principle of disaggregation. We talked a lot about this theory or this philosophy of disaggregation. I gave you the example on our multi-feed system and what we did there to apply disaggregation. The next bit of news is really, really exciting for me because one of the things that we've been working on is a project codenamed Yosemite. Now, what's cool about Yosemite, well, the inspiration behind Yosemite was that we took a look at our heavy compute workloads, and we said, you know, this traditional two-socket architecture that we're so used to in the industry wasn't quite optimal for us. There was wasted resources. There was difficulties around getting the efficiency, sort of the performance utilization that we wanted to get from the device itself. with our software. There was challenges around things like managing and balancing out NUMA and other kind of difficulties that we had from a software perspective. And we broke this down. We said, you know what? We can actually do something better here. And so what we came up with was this package that we call Yosemite, or this design that we call Yosemite. And a little bit about it is that there are 4 sleds to it, or 4 trays to it. Each tray has a 1-socket, basically, computer in it, or server in it. So this is a 4-in-1 design. There's 4 servers here in this one sled. And you can see on the right side here, that card has the CPU, it has memory, and it has an SSD drive to it. So you can boot up, you can do some logging, etc. Now, disaggregation here works really, really nicely because the power, the cooling, the BMC, and the network are all pulled off of this thing. So you can see that the cooling's in the back, the power is in the Open Rack itself. The network card is actually a multi-host NIC that we designed with a partner. And so the network is now off of the actual card itself. So we moved to this 1-socket architecture. What this enabled was that in Open Rack, we can actually put 48 of these sleds in it. So we can get up to 192 CPUs in a single rack. Now, this gives us a huge amount of flexibility because we're going to apply this to other workloads as well. This is going to help us with one of our workloads to get started, but this kind of basic building block of Yosemite is going to get applied to other workloads that we have in the company. Now, this whole thing would not have been possible, and one of the things I love about Open Compute is that we have companies here in this room that are working in the open to bring new products to market. And I think we're building with a purpose, we're building with precision to figure out what these opportunities are, what these services are that we need to build. And we're able to innovate and kind of build these things and come up with the better ideas and bring them to market faster. Now, Yosemite would not have been possible without our collaboration and tight partnership with 2 companies specifically. And the Intel team's going to be on after me to talk in more detail about the processor that is powering Yosemite, but it is a processor that's based on their D1500 Xeon line of processors, which is the 14-nanometer process technology. It is great from a compute to power ratio, so this is really, really powerful in terms of the overall compute to power ratio that we have to manage to when we build out a rack of these things. It gives us nice flexibility, it's very simple, and it's very efficient for us. So we've been working with Intel on this kind of design and this architecture for the last 1 to 2 years, and it's just a great testimonial where companies are coming together to work on this technology and bring it to market. Similarly, the multi-host NIC that I talked about is actually a partnership that we formed with Mellanox. So Mellanox is bringing this NIC that is powering these 4 servers in the sled and is bringing 50 gigabits a second bandwidth to that sled. So we're able to basically, pull off the network card from each card, disaggregate the network. We're able to get better bandwidth. We're able to get better performance, better cooling, and lower cost because of this collaboration. So as I said, the Intel team's going to be on after me to talk more deeply about the actual processor technology and what is powering the Yosemite architecture. But I just think it's a really awesome kind of example of where we are in terms of collaboration and partnership. Now, I just want to close with a couple of thoughts here, which is, one is, you might be asking, it's like, why is Facebook doing all this stuff? And, as I said earlier, I feel like there is just so much more to do here that our work is really, we've got a lot of stuff to get done. Facebook's mission in the world, for those of you who don't know it, is to connect everyone in the world. That means there are 4 to 5 billion people that are out there that we want to connect, we want to bring online, bring on the internet, and bring them the tools and services that are going to be impactful and meaningful to their lives. This presents immense challenges to our team at Facebook. There are all sorts of technology challenges that some of them which we know, some of them which we don't know. So we're constantly working against this goal or this mission to connect everyone. And I think that all of us in this room have similar kind of very big, unprecedented technology challenges that we have to work towards. And for us, I think that we're going to need to work harder and closer together so that we can bring more technology breakthroughs into the community And I'm excited about what we've accomplished in the last 4 years, but I'm really, really excited about what we're going to do in the next 4 years. So thanks for joining us in this journey.